Okay, so how about you give me an example of a cnidarian? Jellyfish, that's right. And what are some structural characteristics that you had noticed from yesterday about jellyfish? They got tentacles, that's true. They've got a round top, so they have radial symmetry. And what else might come to mind when you think of cnidarians? Yeah, they've got tentacles, and inside those tentacles they have specialized cells that produce what? Okay, and can be quite toxic. So one of the aspects that they had talked about yesterday, why is it that some species of jellyfish are so much more toxic than others? And one of the aspects that we talked about in class, why is that? Why do you think they're so venomous to fish? Right. And one of the aspects that I really did not know, what did they say about the digestion of them that actually takes place where? Actually in the tentacles, okay? Then eventually, I really don't know, there's no muscular structures inside these tentacles, so it's not like fingers that we have or anything like what a squid or octopus would have that can actually bring that prey item to their mouth. So I would be led to believe that it's going to be a water current that pushes it inside of there. And then really don't have a true type of digestion system yet. So that means, what type of term does that refer to as far as digestion inside the animal? Yeah, it's going to be intracellular. That's right. Okay, so some unifying characteristics of this phylum. So they got radial symmetry, they have tentacles, and they produce what? Venom. Okay, so that's going to be key. That's going to be something that you're going to see as a reoccurring theme over and over, just like, so we started today off. We're going to start tomorrow off. That same type of discussion. That's how important it is. So how many of you remember the characteristics of the sponges? That's how we started yesterday's. They're sessile. They're filter feeders. They have an osculum. Okay? It's some of those aspects that, you know, we're going over them day after day after day, that we want that information to sink in. I don't like the idea of saying, well, we're lecturing about it, then you just regurgitate the information. Well, that's what it sounds like, but this will come full circle once we get to semester time. It's how we categorize all these animals in the animal kingdom all the way up to the vertebrates. That's next semester. So we've done phylum Porifera. We're in the middle of Cnidaria. Next will be Mollusca. Okay. Then we'll be moving on to Arthropoda. And then if there's time, which looks like there will be, we talk about Echinodermata. And with that, we continue where we left off. And I believe this is fairly close, because I got to do this first. Now we can go back. Okay. I believe this is fairly similar to where we left off. Okay. So what example would we use when we're talking about dimorphism then? What does it mean to go through dimorphism? Yeah, they don't move to begin with, and then movement ensues later on in their life cycle. Of course, there's different types of animals that do that. There are certain species of amphibians that do that. Okay, certain animals go through a tadpole stage, then eventually they lose their tail. And does anyone think they know who that would be? Yeah, it's frogs. Okay, so it's not the only time we see that characteristic. We just apply it at this time. Okay. So this is its own. The phylum is Cnidaria. The class then is Hydrozoa. Okay. Because not only do hydrozoans form that, we see that jellyfish do that then as well. So there again, I can't stress that enough. Here you see that term again. All these animals have these tentacles. But not all delivery mechanisms of venom is the same. Okay? So think of another venomous creature. Okay, snakes. So their envenomating structure would be what? Fangs. Fangs are a specialized form of teeth, right? And you could say the same thing about spiders. Are all spiders venomous? Yes, they are. But are all spiders dangerous, though? There's your answer is no. Okay. There's different reasons that some spiders are more dangerous than others, and it probably has something to do whether you're allergic to them or not. And of course, you wouldn't know that because not everyone has the same type of food allergies that other individuals may have. So it is possible. Okay. So we go from you say fangs to what about scorpions? Do they have fangs? They're certainly venomous. Some of them are actually quite dangerous. Where is it though? It's on their tail. So you could say some have stingers. Even mammals, some are venomous. There's only one that comes to mind. I'd be surprised if someone knew who it was. You find them in Australia. You are really close because spiny anteaters still lay eggs. There's only one other species of mammals that lay eggs. Probably their close cousins. No. They got a duck bill. The platypus. The males, for some reason, evolution chose them to be venomous. Why that is, no one really knows for sure. Probably going back to with social structuring and how they will probably defend themselves for a type of mating ritual. Okay, so we have stingers, you have fangs, but then these guys have these structures, nematocysts, and that's what that video was referring to yesterday. Okay, so this would be a structure much like a fang. It's a delivery mechanism for this venom. And what the video had illustrated is as these tentacles stick out, it's kind of like they referred to as a sock going inside out. And inside that tentacle, you had all these nematocysts, which were like needles that then would eject that venom. So as we look at this term right here, okay, is going to be important. Why would you guess, especially when you look at this prefix? Neuro, for instance. What might that be referring to? In this case, yes, but it is a very, let's say, I don't want to say archaic, but very very basic nervous system, okay? So this muscular structures that some cnidarians use, we said it's not in the tentacles because they can't bring that prey item to their mouth, okay? So there must be some form of muscular structure inside of a jellyfish. Why would they need some muscular movements, do you think? No, not so much that. I say that again. To move. That velum, that structure that you see that has that radial symmetry on top, that flexes. And when that does that, it just kind of propels that jellyfish along, whether it's moving up, down, sideways, left, or right. So in order to do that, you have to have a neurotransmitter send that message through a very basic nervous system. That's right. Okay. Body structures. I just want to see where this puts us in a couple. Okay. I just want to do this one, then we will stop with that for today. So one of the things, okay, neuromuscular system, okay. The reason we call this a landmark of evolution is obviously it's going to be the first type of movements that we see within the animal kingdom, okay? Because as we all know, periferans did not move because they were sessile. Many species of cnidarians are also sessile, but some of them do move, and in order to do that, you have to have a neuromuscular system. And even those that do not move, like sea anemones, which are anthozoans, still have a neuromuscular system inside of them because of what we see here. current and past A and P students? This term right here, peristaltic movements, what might they be referring to? First two, movement of materials, as it says, for digestion. For humans, okay, though that peristaltic movement takes place in intestines. Okay, here this type just takes place inside of a stomach. In general, it means through stomach and intestines, but just for these animals, it's just inside a cavity that does have a stomach. Okay. Does anyone know what it tells you what myelin is? Do we have myelin in our bodies? Yes, we do. There's an article here in Reader's Digest talking about many different articles about trying to make yourself smarter. And there's one in here dealing with certain cases they believe as young football players are developing. Okay, their nervous system is not fully developed yet. So according to this article, when this is still building, okay, your brain's going to constantly rewire itself. But if you don't challenge it, it's just going to, it's not that it stops, but it's just going to sit around there with nothing to do. Okay, when you see some of these posters, I've seen them around the school. When you read more material throughout the day, whether it's a magazine, a book, I doubt textbook for 20 minutes, but as far as reading materials, especially even at your age still, your brain is still consistently rewiring itself. Okay, we call that plasticity, to where, of course, you can always learn new skills. They always talk about that with this cliche when it was with dogs. When it gets too old, you can't do what? Yeah. I guess you can teach an old dog new tricks. I guess I got it wrong. But just the idea of you can always learn materials like this. But reading isn't for everybody. But especially at your age, the more you challenge your brain, the more of this you're going to build. And what it does is it starts to speed up those neuronal contractions. And that's why, especially I suppose when people have certain skills, okay, when it comes to your marksmanship, okay, you can look at your target and your instructor is going to say, well, that's trigger pull, well, that's breathing, okay. Let's say you have this on your trying to zero in your rifle or your weapon. If it's, to me, if it's down this way or down that way, that might be trigger pull. But if it's high, it might be your breathing. Does that sound accurate? It can be one of those two. I might have got it wrong, but okay. All right. Okay. So typically, what do you want to train yourself to do right before you pull that trigger? Yeah, you want to breathe out, because when you're doing that, of course, your muzzle, and it might not be a whole lot, but one of the things when you're doing your hunting and your deer is, would you take a shot at 500 yards? I don't know. That's why I'm asking. What's too far then? Okay, so regardless, if you are looking at 500 yards, when you're zeroing that in on your scope, you don't put that cross right on their front limb, do you? Yeah, you want to go up probably just a little bit on how that's coming out, so when gravity does its job, it might drop maybe about, what, that far, over 500 yards? I don't know. Right. Okay. So that's why I thought it might be about like this. Anyway, regardless, so all of those different types of activities, you get better at them with, of course, practice. So, all right. So we will continue with body structures tomorrow. And for the remainder of time, we'll continue with, I think, was it called Rise of the Jellyfish, I think is what it was called. So we'll continue with that. We'll probably have a vocab quiz sometime next week.